All right, and we're on. Okay, as I mentioned in the description, this stream we're going to be working on exercise 2.3. We're going to be taking some spheres, some circles. We're going to be giving them mass, so that way they fall down with different weights and they get affected by the forces in different ways. Then we're going to blow at them with a little bit of wind, and then if we have a little bit of time, we'll see if we can start having some other forces in there at the same time. Okay, so we're going to use the vector library once again, and let's get started here. So I want to load. Interesting, didn't use. I never know when it's going to use function or not. So I'm going to want width. Did I spell that wrong? Usually it auto-completes for me. Oh, and it wasn't trying to. Interesting. Alright, and let's see. What is next? I'm going to want... definitely to bring in p vector, so... Hi Chantilly, welcome to the stream. I'm also going to want to create a mover again. So this time I went and created a true gist here of a love class. So I don't have to go looking it up or changing things around. I can just use these. And it's really awesome. So when I create this, I want to have a location vector. Say t dot location equals location. Other things that I'm going to need here, specifically a color would be pretty awesome. So t dot color equals. We can have this. I can just say like t dot red equals maybe this. Ooh, right. I'm no longer on my my Mac, so I don't know a good color sync utility. Okay, let's just try something like 100. T dot green and T dot RGB blue. And let's give it a so the size. What we're gonna make the size based upon the mass. So if I have a mass here like this, I actually want to have each of these get a random mass. So bring that in here like that equals mass. But then that means I can do t dot size equals mass times, I don't know, let's scale it up by 16. I believe that's what the examples were showing us in the book. All right, so we're going to have a mass, we're going to have a size, we're going to have a color, we have a location. That should be enough for, circle. So this should really be radius. because when we go to draw, so function mover draw, we can say things like love.graphics.set color, and we'll say self.red, self.green, self.blue. Oh, it needs a fill in here first. Oh no, set color? No, I'm getting it mistaken with circle. Okay, so set color, we're going to do this, and then we're going to say love.graphics.circle. Okay, and so in circle, we're going to want to fill it. And then I believe it is going to be its X and Y position. So self.location.x, self.location.y, and then we want a radius for it. So that'd be self.radius. So that should be good for drawing it. So if we say local mass equals let's do 1. And then we can say local location equals vector.new. Let's put this at let's start with 0, 0. And now we can bring in our mover. Bring in our mover class, and we can say mover object, and we'll do mover equals mover.new. We'll pass it in mass and location. Function love.draw, and here we'll just say mover draw. That should be enough to get this set up. I need to open up my which is it? It is PowerShell. Documents, projects, feature of code, chapter 2, exercise 2.3, exercise 2.3, Love2d. Attempt to index, up value, mover, a Boolean value. Okay, what did I do wrong? So mover does have, oh, return p vector. This needs to be mover. Apparently I missed that one. Let's try this again. Okay, and there is our circle right there. Cool, perfect. So the next thing that I want to do with this is I want to have it be affected by gravity. So what do I need for that? Well, I'm going to need a gravity, I'm going to need a gravity force. So that'll be just a vector, and that's going to push on it to the right, which means I need to apply a force inside the mover class. So let's do that here. Function mover apply force. This is going to take in a force. But here's the thing. I want this to apply the force based upon the mass. So what we can do is I believe I know what the algorithm is for this. I believe it's just divided by. But let me double check really quickly in a book here for. Yeah, okay, so it's divide the vector by the force, and then the mass, and then add it to acceleration. So that's what I need to do. And I do not want to affect the original ray in this one. So what I really want to do, I mean, creating a new one is perfect because now in processing, where this book has its all the examples in here, they have to actually use the static method because they don't want to affect the force, which is passed by reference. Of course, in Lua, everything is creating a new vector, so that's really awesome because I can just do that. So I want to divide the force by the mass that's coming in. So I can say local F equals force divided by self dot mass. So that gives me the local F, and so I need an acceleration here. So I do need to bring in local vector equals acquire vector. And so in here now I can say, I need acceleration here. T dot acceleration equals vector dot new 0 0. While we're at it, I also need a so it's going to be the acceleration is added to what was the word again? Velocity. Yes, that's it. So I'm going to add the acceleration to the velocity, which also starts out with 0. So we want no acceleration, we want no velocity to begin with. And so here we're just going to say self.acceleration equals self.acceleration plus F. Okay, cool. So this adds to our acceleration. Now, this is our apply force. We also are going to need an update. And our update should really take the dt here, because we can start doing things like, and apply force. This should really take, well, okay, force will take the dt here. Okay, so I don't need to worry about it here. I'm going to apply the dt, the delta time, in the main Lua before when I hand it the force at this apply force. But when I'm actually affecting the circle here, I'm going to say self.velocity equals self.velocity plus self.acceleration. Once I have the velocity, I'm also going to want to change the location. So self.location equals self.location plus self.velocity. Now I want to reset acceleration. So self.acceleration equals self.acceleration times 0. So that will reset that to x and y of 0. Okay, so I believe these are the basics here of what I want to do, and we have our mover class, we have location. I'm also going to want local gravity. So let's see if we can get it working with gravity first. So this is going to be just a vector dot new 0 0. Sorry, this is not 0, so it's moving downwards, so that the 0 is the x, the y is negative 0.1. So just like a slow crawl down. I actually believe I'm going to need to make this significantly larger. How about -5? Let's try that. And then I need an update. So function love.update, and we'll just say mover apply force, and I want to give it the gravity times the dt, and the dt comes in right here. Okay, a lot of code. Let's see if I do this correct. No, I did not. So the code works, the ball doesn't fall down. It just stays there. So love update, mover apply force gravity. So there's the update. We have the draw. Apply force is in the update. And then we have mover draw. Okay, let's see. Why is this not going down? Or is it going down really slowly? Let's find, because this is force divided by self.mass. Let's try making the gravity really big, like 50. Still doesn't look like it's moving here. Okay, so let's find out what's going on. We have mover to draw. We know that's working. Mover apply force gravity times dt. Let's make sure this is running. So print, let's do force dot x. Let's find out what that is. Okay, that's 0, so that's good. And y should be the number from that. It's down by less than 1 pixel at a time. That should still move it. I don't want it negative, don't I? I want it positive. Because if it's positive, it's moving downwards. Is that the problem I had? No. So the apply force, apply gravity. Gravity is a vector 0x, so don't move left or right. We have a y, so we want that to move down, so that's positive. And we gravity times the dt. Because if I leave the dt out, if I just pass it in gravity, I thought so. I just wanted to double check. So y is, so acceleration is supposedly changing. We can verify that maybe. So self.acceleration, self.acceleration. When we update, so, oh wait, am I never calling the update? Oh, that's so silly. So then I need to do mover update. Just call that. Oh, so silly. Now it falls. Let's try something slower, like 15. Okay, that feels a little bit better. Okay, so that falls down. Something that would be really nice is when it hits the bottom, it bounces back. And I can do this with a function check edges. So if, and I'm just going to do the center of the balls right now. I'm not going to worry about the trying to find the edges perfectly. So if self, and this is not that, I need to do mover colon check edges. So if self dot location dot x, so we can do left and right first. So if x is less than 0, and I can say left and or equal to 0, then it keeps on happening. Okay, so then I want to set self.location.x equal to 0, and then self.velocity.x equals self.velocity.x times -1. So let's reverse it. This becomes now moving to the right if we were moving to the left and past. And okay, so else if self.location.x is greater than or equal to width, then self.location.x equals width, self.velocity.x equals self.velocity.x times -1. Okay, so reverse it again. And there, but I also want to check the y, but just on the bottom. So if self.location.y is greater than height, then self.location.y equals height, self.velocity.y equals self.velocity.y times -1, reverse that, end. Okay, so then I need to check the edges after doing this. So mover check edges. So let's see if that works. Then expected near y. Okay, did I miss a then? Where was this? Syntax error, mover class, line 47. If self.location y is greater than height, then, well, there's a then right there. I think that is right there. I think so. So if self.location.y, okay. I put a space in there by accident. Hey, look at that. Okay. So something interesting to note here. As it's bouncing, it started up here, but as it's bouncing, it is very slowly getting lower, except sometimes when it gets all the way back up. But it's not moving at the full amount, but I think that's because of the division. and our delta is affecting it in interesting ways, because when I moved it there, that stops the time and it changes how much it's divided by. I think it's an interesting thing, and I'm not sure it's exactly what we wanted. What I could do is when I apply the force, so I apply the gravity here, I can maybe change this to gravity comma dt, and in apply force delta time, so local F equals force mass, and then I can just maybe apply self.mass times the delta time. Let us try that one. I'm still getting a little bit off on this. I don't know if the order is working here correctly or not. Also, my undo doesn't seem to work here. Oh, no, it's just my keyboard stopped working. That works. Okay, so now I should be able to undo that again. Okay, so if I bring in delta time, maybe this is the wrong place. I want this to happen first. So self.acceleration plus f times dt. Let's see if this is a lot better. And if I move it, oh no, same issue here. Okay, I'm not exactly sure how to deal with this. It might be, this is one where if I knew Love2d a little bit more, I might be able to work around it and figure out how to deal with the unknown amount of time. But with that not being the case, I am going to just not worry about it too much and put this back to the way I had it before, because I think that was fine. So apply force, this becomes multiply. Okay, cool. We're back here, and so it's bouncing up and down. Now what I want to do is have a wind moving it to the right. So this one, let's do a positive 0.1. Oh, I keep on forgetting. In Love2d, because of that delta time, I do need to have it significantly more. So if gravity is 15 down, maybe we can do a even gravity. So it's moving to the right at a 15 clip as well. And it's moving down, nothing at all. So let's also mover, apply force wind times dt. Okay, so it's always fun to see this happen here. So basically it's trying to be blown to the right, and that's really awesome. I love seeing this. The only negative here is that when I go to move this screen, it kind of screws it up a little bit. I wish there was a way, instead of going to the center, I can tell it, hey, just go into the left. Okay, so let's create a local instead of movers, let's create a movers. And what we're going to do is we're going to say movers equals an empty table. And then, okay, so we set our mask, we set all this stuff. Location, okay, so I want this mask to be random. So I can say for, let's see, I equals 1 to maybe, let's try a small number 5. Do I believe, do like, so set mass equals to love.math random between 0.1 and 10. Then our location, this can be, we can be all the same. It can start in the same location. So vector new 0, 0. The mover, so instead of mover new, we can now say table dot insert or add. I think it's insert movers, and then that's what to insert is. I'll find out really quickly if this doesn't work. Gravity doesn't get changed here. We're not gonna do that. So this is end. Okay, so do this 5 times here. We'll set these up also. Now when we draw, we're just going to draw this multiple times. So for, let's see, I value, but I can also just call this mover. In I tables. Ah, man, now I have to go look it up. I did that once and I haven't looked it up. Lua for loop table. So iterators, I pairs, index value, key values in pairs T, so for index I mover in I pairs T. I pairs, and then this is the movers table. Do mover.draw, end. Then I need to do the same thing up here. So for I mover in I pairs movers do end. Let's see if I now get 5 balls. I get 5 balls. That is a huge ball. But also notice how it's moving a lot slower. The mass is being affected differently. So this is really cool to see that there was a really tiny ball here, and I think I ended up getting shot out of the screen. That reminds me, I want to figure out how to set the size of the window. get dimensions. Oh, there's a config, isn't there? Where would that be? Config files. So love.conf. This is what I want. Okay. So we're going to create a love.conf here, and inside of here we're just going to say function love.conf t okay, so t dot window dot width equals yeah, let's just let's go to 1024. Let's try that. T dot window dot height equals, I'm okay with staying with a, we can do I think it was 800 by 600 before. Let's try this. So back to here. That didn't affect it. These are all really big. Love.conf. So that's here. Unless that is 1024 already, I can do 2048 just to see. No, that didn't affect it. It's still the same. It looks still the same. Or did I not do this correctly? Function love.conf t. Oh, it's conf.lua, not love.conf. Oh, overwrite the love.conf. Oh man. Okay. I did not read that correctly. Let's rename. This needs to be conf.lua. That's what it needs to be. Okay, that's now a bit large. Let's drop this down a bit. 1500. I don't really care about the aspect ratio right now. The idea is now we get a lot of time to sort of play with this one. There's a teeny tiny circle right there. And it's almost rolling on the ground now. That's really fun to see. Now it's so tiny, I don't have no idea if you're going to be able to see that at all. I can barely see it on my screen. So what I think I'm going to do is in here we're going to change this. So instead of, for the mass, instead of 0.1, we can do 0.5 maybe. 10 is a little bit big. Let's go down to 7. Do 7 at 0 to make sure it's okay with the math. Okay, so we're starting with that location still. Now, of course, this is not perfect physics simulation. The next chapter of the book is going to be talking about how to make sure that the balls of different sizes fall at the same rate, like how normal gravity works. But this is showing how these balls do have different mass and they're being affected in a different way. Now, the last part of this exercise is to have a special force that comes in from the right and pushes against this this wall here, and attempts to not let it hit the wall, but sort of push it back. So let's see. I don't actually know how I would calculate this, so I may just use some kind of guesswork. Okay, so what's the M here? I don't think I'm using that. That must have been a typo. Or was that the mass? No, that wasn't a mass. Okay, I don't know what it is. Okay, so what I want is another vector. It's going to be maybe the wind from right. Wind from right equals vector dot new. So here's the thing. How do I know? Oh, okay. I may not be able to do this here. So the reason, because I don't want, oh, nope, definitely don't want to do that. The reason why I don't want to do this here is because I need this force from the right to be almost nothing over here, but extremely strong right here. Meaning that it needs to be dynamic and change it, which means I can't just set it statically here and have it be fine. I need to set it every time I do this update. So when I apply the force wind here, I also need to create a new local variable and maybe set it based upon the X location of where the circle is. So if I say local wind, maybe I'll just call this left, right wind equals vector, no, uppercase vector dot new. So its X needs to be based upon the mover. So mover dot location dot X. So as it's moving to the right, X gets larger. That's good. That's how much force I want to apply. So what if I just take that and multiply it by -1? And then I have 0y there. Then after I apply the wind force, I can say mover apply force right wind times dt. Okay, so that apparently is way too strong of a wind. The right wind is now not even letting it get far away from the left wall. So maybe let's scale that down by a bit. So instead of just times -1, if I do something like -0.5, that cuts it in half. Theoretically, it'll get just a little bit beyond here. If I do 0.1, let's see how far left that lets it get. Well, now it's too weak. It hits the right wall. So I don't need 0.1. How about, well, how is 0.1? Oh man. So those 0.10 is a huge distance right here. So 0.1 is still too weak. So I need something here, but 0.01 is way too weak. So maybe 0.05? Almost reaches halfway. How about 3? So this is where the guesswork comes in for me. I'm sure there is a mathematical formula I could actually use to predict this. Oh man, that's so... Is this really going to be just 0.02? It's getting so close to the edge. I think it actually is touching the edge, but it's so close. It's like it doesn't really want to. And it kind of looks like it's not hitting the edge. We can verify if it is in our check edges. If we are to the right, if we're to the right, then we can also print out hit right edge. So far I've got nothing. Alright, that's good. So I managed to accidentally hit in the area where it just gets really close but doesn't actually hit the right edge. That's perfect. So let's scale this up. Oh, one of them hit the right edge, but it's... Oh, it's after it's getting all this extra speed. I'm okay with that. Okay, so in here, let's scale this up. So instead of going 1 to 5, let's go to 100. This doesn't feel like 100 circles. It still feels like it's 1, 2, 3, 4, 5, 6, 7, 8. It feels like it's 8 circles. Unless it's got a lot of the same size, the exact same size. Let's also not go up to 7, that's too large. I still feel that's pretty large. You can go back down to like 0.3. Three. Feels like it's even less. 1, 2, 3, 4. Is it really giving me that many? That high of a variation? Now I could just do this. So take the mass, it'll be a random number between 0 and 1, and I can just multiply this by 5. Oh, there we go. Now I get a wider variety. Okay, so my random algorithm was definitely not working. What's interesting is because the mass is not taking, like when it's dropping with gravity, it's not really doing the physics engine properly. So they all drop at different rates. But after a short while, you just sort of forget about that, and it all looks really interesting. Let's give these things a random color. random. So I want this between 0 and 255. And now we're going to have crazy color balls flying everywhere. And so that's what this challenge was. This challenge was to apply a new force, wind, along with gravity. So we have the vertical movement, we have the horizontal movement, and then we also have this dynamic force pushing from the right that's getting stronger as we reach the right-hand side, and then just create a whole bunch of things and of different masses and let them fly. It's a lot of fun to sort of see this get affected and go out. But with that all said and done, this is it, the end of the challenge. So, I normally been streaming on Mondays, Wednesdays, and Fridays. This weekend is going to be the Ludum Dare game challenge. Well, it's kind of a hackathon. For those of you who know about it, I am going to compete in it. I am going to do the compo version because that's only 48 hours, and I really don't feel like doing the 72-hour version. I'll be doing this on my own, and I plan on streaming as much as I can during that time. So I will be here on this channel doing that this weekend. The competition starts around 7 p.m. Mountain Standard Time, or Mountain Daylight Time right now. Yeah, and Am done on Sunday, regardless of whether or not I have a completed and playable game. I am planning on using the Love2d and Lua stack that I've been using here, and it'll be a lot of fun to put together everything that I've been learning with Nature of Code into this game and see what I end up being able to do. So, thanks guys for stopping by and checking the stream out. I have a great night, and I'll see you guys next time.